it on automatic, so it should be able to pick my server. Before I was using Taipei, which was the closest server I had to where I was before. So now I am hoping this is better. I'm so sorry about that. Wait, you just noticed that's Attack on Titan? Oh, on my background, right? I'm getting so many emails from work right now. Like, okay, let me just bring my screen back up, and also let me make sure I'm not gonna accidentally show anything embarrassing. Okay, I think I'm okay. Right. Hello, welcome back. Sorry about that, guys. Thank you, by the way. Who said that? T.S. Joss, thank you so much for bringing that up. I had forgotten that I had to specifically manually set my previous server because it wasn't choosing the server correctly. We'll check to see if there's a problem with the we'll check to see if there's a problem with the buffering now. Probably there shouldn't be. That's probably the issue. That's what I'm hoping for. But if you guys have any problems, let me know. Just if there's any buffering or anything like that, let me know. Hey Doe, what's up? And anyone else who I didn't say hey to, hey, thanks for being here. Okay. Man, I was so frustrated. I get so frustrated when, like, you know, I don't know. I'm frustrated with the US in general as a country. And especially when I'm coming from Japan, I tend to find that there's a lot of things here that are just, you know, I dealt with them when I lived in the US and then I left the US. And now that I'm coming back, I don't want to deal with them anymore. You know, that's kind of where I'm at right now. So I don't know. It's just little things, like stupid little things, like people being people, you know, like, it's something like that. Come to the EU. So my girlfriend is considering, a position in Copenhagen. I pronounce it Copenhagen, but maybe I'm pronouncing it incorrectly. But yeah, so, she's considering a position there. And that I might consider going there as well. It kind of just depends on a number of different factors. It's that helped me. I can definitely pronounce that. But anyway, I have no problem moving to Europe. Is the thing. I definitely don't. Again, Scandinavia is great for the quality of life and stuff like that. What we have set right now is because I'm currently working at MIT. She currently will try to find a place in Boston first, and then if she doesn't find a place in Boston that she wants to work at, then she's also applying for a Marie Curie fellowship in Europe. And if she wants to go to Europe, that's fine. I don't mind. I think that's actually great. I would genuinely. It's kind of a situation. I don't really care where we go, as long as we go somewhere together, type of thing. I hate being in a distance relationship at this point. I've been in a distance relationship since November, and now because of the coronavirus, it looks like we won't even see each other until like July or something this year. Actually, I guess it's been since October, really, that we've been in a distance relationship. So it's tough, you know? Like, I'm not going to sit here and gripe about it. Like, I'm not particularly into relationships, neither is she, but at the same time, it's like, come on. You want to get your life started, and it's really hard to start your life when you don't know where that life is going to start, you know? So that's kind of where I'm at, and I'm sure a lot of people are the same. Europeans want to go to the US, Americans want to go to Europe. No, I actually would love to go back to OIST. Like, so for those of you who maybe weren't here before, you don't know where I'm from, I just came from the Okinawa Institute of Science and Technology, or OIST. This is where I came from. Like, I literally was here for the past 5 years, and my girlfriend doesn't want to work in mainland Japan. She is Japanese, and she knows that there's a very weird work culture, you know? In mainland Japan, where people have to work all the time and it's a pain. But in OIST it was different. OIST was international, and I would absolutely love to go back here full time as a professor. That would be my ideal job, working here full time, and not only working here full time, but also, you know, doing my online content. You know, I want to be able to be an independent researcher, and I think that's my number one job. But my number two job is professor at OIST. It's pretty darn good. This place is amazing, and if you have the opportunity to go, man, just definitely go. This place is so great. I spoke to a lot of the previous students who just left OIST, and man, I don't think I've heard a single positive story about the students after they left Japan. Like, don't get me wrong, like, they're doing very well for themselves, but a lot of times, like, it's just compared to OIST, no matter where you go, isn't as good. Like, that's just what I found, you know? Japanese work culture is bad. Hashtag not all Japanese companies. right. It's not all Japanese companies. Like Oyster is a Japanese company, but it's not all bad, you know? Like sometimes it's fine. And I think Oyster was in that. Sometimes it's fine, you know? And I think a lot of people are acknowledging that there's an issue with Japanese work culture, and a lot of people are trying to fix it. But that doesn't mean that, you know, that doesn't mean that the majority of people, that doesn't mean that the majority of people who work in Japan are okay. You know, the majority of people are probably in trouble. I'll try to apply next year after my master's. Right, if you have questions about what Oyster is like or anything like that, feel free to ask. I genuinely like, I loved my time there, and I feel like a lot of people will also love their time there. But you have to keep in mind that it is remarkably different than graduate schools elsewhere. So, you know, I'm not saying it's the best for everyone. I'm just saying that for the people that Oyster works for, it works very well, if that makes sense. Okay, I'm not going to talk about COVID anymore. I just want to say, finishing up the conversation we had just a second ago, I know it's a big deal. I know a lot of you guys probably at home right now, specifically because of COVID, and you guys are afraid to go out because you're afraid you're going to just, you know, get all your friends and family sick. I get that. I guess we just have to bear with it for a bit longer. Again, my sister definitely told me this morning that it's pretty bad, and I think we should all be doing everything we can to make sure it doesn't get worse, you know? Also, guys, let me know if you have any troubles, not only with the dropped frames, but if there's audio quality issues, like, you know, if I'm railing or whatever it's called, where like my voice gets too loud or whatever, let me know. The problem is I'm in cryptography. I'm not sure they have researchers specialized in that. They probably don't. I mean, that's the issue with a lot of the things at OIST. They don't have specific, like, they didn't really even have computer scientists when I was there. If you go to OIST right now, let's just go to admissions.oist.jp. If we just go here, important update. Well, this is different than what I was expecting. Ongoing breakout of COVID-19. What is up with this site? Are you kidding me? Due to ongoing outbreak of COVID-19 and subsequent international travel bans, restrictions to June 2020 admissions workshop and interviews will be conducted online. The application deadline, however, will still remain the same as advertised. And I want to do research. Faculty and research. So, come on, why? There we are. So like if you go to mathematical and computational sciences, a lot of these guys aren't mathematicians. Like a lot of them are just other people that happen to do a bit of math in their unit, and think that they could handle a mathematics and physics student, right? But some of them are. So as of now, we've got a whole bunch of new people coming in that do a lot of math and physics, and I think or do a lot of math and computer science. So I think that's good. But I will say that a lot of times, if they're on this list, that doesn't necessarily mean that they are mathematicians, right? The problem is I'm in cryptography. Luckily, we already socially distanced by default in Sweden. I think that having to work from home mostly impacts the extroverts. Yeah, I'm doing nothing different than what I normally would do. I think that's true for a lot of people. Like, for example, I'm not doing anything different than what I would normally do. I normally don't go outside. I normally don't socialize with people in that way. I know it affects a lot of extroverts more than it affects introverts. But I will also say that this affects everyone, right? Our economy is actually based on extroverts when you think about it. You know, bars, you know, restaurants, these are things that people live off of, you know, like money is put into the economy. This is where you make money at your job, and this money goes somewhere, right? And the question is, where does that flow of money go? And right now, because so many people are working from home, the flow of money goes in very weird directions now. Like now, all of a sudden, everything is online, whereas before, I would say not everything was. Like it was going that direction, but now it's solidifying the hold the internet had on the economy. And I think that's an important shift. I don't think the economy is going to crash, but I will say that I think it's going to change after this, and it could change for the better or worse. I don't know. But I've been thinking about it a lot. And yesterday I was really worried about like a Great Depression era type of thing, but I'm not so worried about that anymore. I think the economy will bounce back. It'll just bounce back in other areas, and a lot of people will lose their jobs. And then a lot of other people will find it again somewhere else. Our economy is based on sociopaths. Steam sale numbers are amazing right now. My YouTube video numbers are amazing right now. Like there's so many people watching. There are so many people watching my YouTube videos right now, compared to what they used to do, you know? And one other thing I want to point out, or one thing that I thought was kind of funny, was that one of the most popular videos right now from my channel is the what is it? It's the stable marriage problem, which says to me that a lot of people probably have unstable marriages, which is a bit weird. I should rewatch your video sometime. Well, we're making another one today, so hopefully tomorrow evening or maybe Monday sometime, we'll have another video out. I usually put videos out on Saturday. I think I'm actually going to be putting videos out on Sunday morning from now on. I think that's going to be the time that I shoot for. But this particular video, I don't really have like big plans for. I just want to put a video out and then I'll worry about scheduling it afterwards. So we'll see. I've seen prices on PC equipment raising since the lockdown. There's a lot of things that are, I don't know. There's a lot of things that are weird now, and I don't know. I don't know where the economy's going. I'm not an economist. I'm not a healthcare worker. I don't know these areas. I guess you could call me an expert in physics and computer science, but you've seen this stream. I'm really not an expert in either one of those. I'm just lucky to have a job. That's kind of where I'm at right now. I don't know. We're in a tough situation as far as the coronavirus thing is concerned. So if you guys are struggling with it, because I know a lot of tech workers, feel safe, but a lot of them aren't. Like I know a lot of people who actually are struggling career-wise now because of the coronavirus. And so I'm hoping that if you're one of those people who are struggling or see people struggling and you're worried about it, and maybe you're struggling to stay at home because you're an extrovert on the inside, I hope that you come here, enjoy your time, and we can just go ahead and get started. Okay. So that was a bit of a long ramble session. I'm sorry about that. Today's going to be a bit of a longer stream, so I don't mind it being a bit of a longer ramble session at the start. But yeah, we're working on Gauss's Easter algorithm. So the primary goal of today's stream is to do some visualizations, specifically visualizations that I will put into a YouTube video that should come out either tomorrow afternoon or Monday morning. That's what I'm shooting for. So there's two visualizations that we need to do. And I'm going to go ahead and show those visualizations, like draw out those visualizations, and then we're going to start to try to figure out how to make them. So let's open up Zernal PP. And again, guys, if you have any comments, questions, concerns, ideas, anything like that, feel free to let me know, and I will do what I can to answer them as soon as I see them in chat. So for those of you who may not know, we are specifically talking about Easter. Right? So Easter is... I have so much trouble writing R's. R's are like the hardest character for me to write. Easter. And even when I draw them correctly, my R's are still crap. Like, I think some people have like a really weird impression of me, and then they see me write, and their impression like completely dies. Like they're like, oh, this guy knows what he's talking about, and then they see me write Easter, and it's like, no, he writes like a 5-year-old. He has no idea what he's talking about. This is why I don't teach lectures. Okay. So the problem with Easter is that it is a very important date in the Christian calendar, but the big problem is that people didn't know how to calculate this date for the longest time. What it is it is a mix of two calendar systems. So of both the solar calendar, which we'll call the Gregorian calendar, Greg, and the lunar calendar, which we'll call the lunar calendar. So the Gregorian calendar here is, your typical 365 days of the year, and your lunar calendar is basically, 29.5 days before your moon is before your moon returns back to its original phase, right? So if you're plotting these out, you'll have, you have your sun here. You've got maybe I'll do it in yellow. Let's color code this a bit. So you have your sun in the middle here. Then you've got your Earth over here, and then you've got your moon revolving around that. So, it's going to be going all the way around here, right? And then your Earth is going to be going all the way around. Ooh, do I have enough room for this? Let's pretend I do. All the way around here. Right. What's the 0.5? Or rather, how does the algorithm factor in that 0.5? It factors in 30. And then after factoring in 30, it makes a correction for the 0.5 afterwards. And the correction for the 0.5 comes with, let's see, CD projects, algorithm arc, Simuleos, and then Computus. And let's hear, it's going to VI Gauss's Easter.jl. So it corrects for the 0.5. Where does it correct for the 0.5? It corrects for the 0.5 in... What does it do again? It does the... I think it corrects for the 0.5 down here. Oh, I don't remember exactly where it corrects for it. but this is where I wrote it down. So for high values of D, and D is the number of days since the start of spring to the date of the Lunar New Year, you could be off by a bit because it's 29.5 days, not 30 days off. And so you make a small correction where sometimes you remove a week. So shouldn't it be 365.25? Yeah, you're right. It should be 365.25. You are totally correct. 0.25. Right. So, wait, does the moon actually revolve around the Earth every 30 days? Am I drawing this depiction right? A moon around Earth 30 days. Is that correct, or am I just completely off base here? Orbit of the moon. What do we have here? The moon orbits Earth in a prograde direction and completes one revolution relative to the stars in about 27.32 days. Yeah, okay, so 27 days. Why do I have 29.5 down? Orbit around Earth is 29.5 synodic. What's the difference between synodic and sidereal? Oh boy, learning something new. Synodic month. Synodic month is the average period of the moon's orbit. Oh, right, average period is 29.5. Okay, fair enough. Actually, does it handle the 100-year thing with leap years? See the first sentence of the article? You didn't read the second half of the sentence. Wait, what? I don't know what sentence we're talking about. Yeah, I have no idea what we're talking about. Are you writing Python script to compute the date of Easter for a given year? So we already have a Julia script. What I need to do is I need to finish this up. I need to basically put this into the algorithm archive. So that's what we're working on next. Let's see. Flask, I guess you're kind of new here. The kind of goal of this stream is just to learn about algorithms. So we have this book online and also my YouTube channel where we just talk about algorithms and stuff like that. So, you know, if you want to learn about Monte Carlo, you go here, you learn about Monte Carlo and, you know, whatever language you want. Here's emoji code for fun. The moon orbits Earth in a prograde direction and completes one revolution relative to the stars in about 23, and one revolution relative to the sun, 29.53. Yeah, right. So let's see. Yeah, that's exactly right. So a synodic month then. And now I'm confused because I was pretty sure I did read that. So now I'm confused as to what I didn't read. He's not writing a Python script. He's writing a Julia script. Right. Yeah, that's true. Just for precision. Okay, fine. It is 24.2425. That's totally fine. We can do that. 2425. Okay. So I want to do a few visualizations here. The first visualization I want to do should be relatively straightforward. I just want to show the Earth revolving around the sun, and then the moon revolving around the Earth, where there should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 cycles. There should be 12 cycles of the moon orbiting the Earth every time the Earth orbits the sun. But there's going to be a small offset here of 11 days. Ooh, let's try to make that more of an angle. Okay, that's not going to work. Let's try this one more time. We're going to try to make that an angle. Oh, shoot. How do you make an angle? Okay, there you go. Perfect angle of 11 days offset. And this 11 days is important because it helps us understand two things. One, it helps us understand where the 19a minus m comes from in this equation. Plus m, sorry. This equation. And it also helps us understand why there's a 19-year cycle for 19... oh my gosh, what is it called? There's 19 years. There's a 19-year cycle, and it's called the metonic cycle. There we go, metonic cycle, where the moon takes a while to line up. Thanks, Amaris. Appreciate that. So you have a leap year every 4 years, except for every 100th year. That isn't also a 400th year, right? So that is taken into account with this. K minus Q value here. So the idea is K is going to be 4, and then you subtract Q, which is sometimes 1, so that you get 3 every 400 years. That's how it is. So that's kind of the way that's taken into account. There's a lot of weird things that are taken into account. Now again, I didn't get much work done yesterday or this morning, meaning I haven't yet finished the algorithm archive article for this, but I want to get this visualization done today. That's my main goal of today's stream, to get this visualization done. Now, what's probably going to happen is I'm only going to be able to get this one visualization done, but there's another visualization that we're trying to, I still haven't fully figured out yet, related to all the different clock cycles we have going on in this algorithm. So I think we have 6 of them. We have the solar, we have the lunar, we have the metonic, we have the weekly. What other calendars do we have here? I feel like there's a few other calendars here. Solar, lunar, metonic, weekly. I don't know. There's probably a few other calendars here, but the point is, like, we have some sort of dial on each of these, you know, related to where they are on the, where they are, you know, on their own respective clocks or whatever. And basically when, you know, I don't know. Kim IQ is the number of missed sleep days from Julian calendar, isn't it? Yes. According to Wikipedia, it's also called, I tried to pronounce that before, Ennedecateris, I think is how it's pronounced, or something like that. Ennedecateris or something? Someone corrected me when I tried to pronounce that incorrectly before. I'm sorry, guys, my pronunciation is awful. I genuinely do try to pronounce things correctly. Sometimes I get it, sometimes I don't. Point is, I need to find a visualization for how to do these dials appropriately. I'm not sure exactly the best way to do that, but I do very much like this visualization, and so I do want to make this visualization here, and I don't think it would be too hard with the tools that we already have. So, let's give it a go. Let's see, Ennedecateris. I think that's what I pronounced, isn't it? Am I wrong? There's this. Okay, let's take a look. So that's what we're doing. We're just going to do a visualization today. That's our goal. Right, there is this. There is this to explain what the metonic cycle is. And I just don't think this gives anyone any intuition as to what's going on. That's my big problem, right? Like, we need to provide, we're selling intuition, right? And this has no, I just, where's the intuition to this? I see none. I mean, I see some really cool looking people. I mean, look at this guy. Not that. I meant, look at this guy. Wow. I wish I was this guy. But you know, I think it might be helpful to combine the lunar and solar dials into one metonic one. I think you're correct, but I think I want to talk about that after I make the next visualization, because then the two hands coincide at the completion of each. Yes, that wouldn't be a bad idea. In fact, maybe. Okay, you're making me rethink this whole solar-lunar thing. I think this is a cool visualization, this one. But if you have... Oh, I need to think about this. So you would have... How would that work? So you wouldn't have to actually draw the metonic dial. Journal new page before. So we'd have a giant circle. Let me just draw a circle here. So here's your circle. Okay? And then you would have a solar dial. Oh, that's a circle still. Let's try changing this again. You'd have a solar dial here. Ah, come on. One day I will be able to draw something. Draw an arrow. Ooh. There we go. You have a solar dial. Let's try that again. You have a solar dial, and then you'll have like a lunar dial, right? And if the solar dial and the lunar dial are like this, no, this doesn't make any sense, does it? I was gonna try to. I wanted to make it so if they match up. Let's see. I could set it so that the solar dial goes from 0 to 19. No, that doesn't make any sense, does it? The solar dial should go from 0 to 365. That's what it should do. And then this guy, well, 365, yeah, whatever. And then the lunar one should go from 0 to 30 or something like that. And so the lunar dial goes 0 to 30, 0 to 30. Right. Right. And then they should line up after 19 years. That should be what happens. They should line up after 19 years. So that they both arrive at this point again. And then they both restart the cycle. That's what should happen. That's what I'm shooting for. So that's how we could do that visualization. I think that's actually a pretty good way to do that visualization. Right. And so the question is, do we need to... I think we still need to make this animation. I think. Right. I think this animation is important. Right. So let's just jump into it. Let's see what happens. Are you making an anti... I don't know what that is, so my answer is probably not. Basically, each hand has its own period. Let me get some water, and then we'll keep talking about this. But I think... A definite maybe. What is an Antikythera? What is that? Should I know what that is? Some ancient mechanical planetarium thing? Let's take a look what that is. Maybe that's what I need. I don't know. Here we go there. And let's paste it here. We'll remove that, and let's see what this is. Oh, yeah, this is completely useless. This is definitely not what I need. Oh, wait, maybe it is. No, I don't care about this guy. I want to know what the mechanism is. No, I don't know. Okay. So we'll just keep going here. Again, I'm not expecting there to be too many people on today's stream. I don't think I really even adequately told people I would be streaming at this time, so chat might be a bit quiet. It's relatively not quiet right now, but, you know, just feel free to say whatever you want in chat. No big rush there, but I do want to get this visualization started. So let's go ahead and get working on that, and we'll just work. That's what we'll do. CD, actually, I think what I want to do is just do all my visualization in this directory. I think that's what I'm going to do. So let's go to VI Gauss visualization, I guess is what I'll call it. Okay, and we'll just do a C++ file. We'll go from there. TS Joss, whatever you want. I'm sorry, I just hit the microphone. I hope that wasn't too loud. But yeah, if you guys have any comments, questions, concerns, ideas, anything like that, feel free to let me know, and I'll do what I can to answer it as soon as I see it in chat. See what I want to do here. 76A dash. What happened there? 76A dash. There we go. That's what I was looking for. And then we'll just do this. Paste, and let's see. I'm kind of blanking on how to do C++ at all right now. So let's do something like that is what I'm looking for. Okay, and we'll do... Okay, I'm just going to do Gauss visualization.cpp. Okay. I like to put the comment block on the start for visualization code because sometimes I don't create a makefile, and I know I should create a makefile, but when there's like a simple, when there's just a simple like it's just one file, I don't really see a need to make a makefile for that, so I kind of, you know, when you're going to light that sweet fireplace, the fireplace that doesn't exist back there, yeah, it's not even a fireplace. It's just like where a fireplace is supposed to go. That's all it is, so... let's just do a... yeah, I mean, I know, I probably shouldn't do this, but I like doing this. Okay. Let's just do purpose. Simple visualization. For different scenes. Let's see. For computers. Video. Oh man, that doesn't quite fit, does it? I'm just going to put 2020 on this line. And then we're going to move down here. And we're just going to say notes. And compilation. Okay, so now I'm just going to go over here and we're going to CD into projects. I don't remember where I put my visualization before. I'm sure I have some visualization we were working on. Probably for the iterative function system. Simuleos and then IFS, probably. Probably fractal. Probably what I called it. lsstar.cpp. And let's just take a look at VI Sierpinski. I know it's misspelled. Just deal with it. I'm sorry about that. .cpp. And these are the same compilation instructions. So I'm just gonna grab this guy, and I'm just gonna put it over here. We're just gonna paste that there, and right. I think I'm gonna do something like this. Oh well, it is what it is. It copied each individual line when I wanted it to copy one big line. Okay. Something like this is what I'm looking for. Okay, so here are our compilation instructions. What I'm actually going to do, because I'm what you might call a noob, is, well, I think I'm just going to copy some stuff. I think that's what I'm going to do. Actually, now that I think about it, probably that's what I should have done to begin with, because you know me, I'm a big copier. Okay, I also kind of always forget the syntax of what we need for GathVL scripts. I'm just not that good. I mean, look, I know I should know this. I definitely should. cd GathVL, ls and the vi viz script test dot cpp. I've been thinking about, okay, look, the truth is, if I had the time, there's so many things I would do if I just had the time. We'd be in a much better position if I just had the time, you know? Like, I don't know. I always tend to, I get down on myself because I don't spend enough time on stuff that I really like, you know? I don't know if other people are like this or not, but I certainly am. I tend to find that there's a certain subset of things that I really like to do. But those things are kind of sort of similar to work, right? And so I feel like, you know, like for example, programming is something I genuinely like. I love reading about algorithms, but the problem is because it's so similar to my actual work, but not my actual work, if I'm reading about an algorithm, I feel like it should be an algorithm related to the work that I'm doing. It shouldn't be related to some random thing I'm doing on the side, you know? And so I tend to, all of my hobbies and stuff, I tend to just throw away, you know? And this happens quite frequently where I want to get something done. I want to do something cool. I want to, you know, like do something creative and fun. And I end up not doing that because I feel like guilty for doing something that's not work, you know? I don't know if that makes any sense. Specifically if that thing that's not work is very close to work I'd be doing anyway. I don't know. Hopefully that makes sense to someone. The Antikythera mechanism was used to predict eclipses. That might have been useful, but the Egyptian calendar was 365 days. It was drifting fast. Right, so the Julian calendar is 365 days. Sorry, still talking about the mechanism. No, it's cool. Thanks so much for that. Okay. So let's just jump into it. I don't know. I don't know if that's still a meme. Is that still a meme? Do people say let's jump into it? Is that a thing? This is something I should know, but I don't. So let's just pop here and paste there. Okay. Julian is 365. No, that's Gregorian. The Julian calendar is 365. Are you a teacher? I mean, not really. Why would you separate work and fun in the first place? Maybe they don't need to be separated. Right. Julian calendar is, let's see. Wait, are you telling me that the only difference between the Julian calendar and the Gregorian calendar is actually the 0.0025 at the end, or I guess the 0.0075 difference between the two of them? That could be true. I just find that kind of hard to believe. Let me see. What do we have here? I'm just going to go to... I thought... Okay, Julian calendar. I just opened up the same link. Let's try that one again. Okay, Julian calendar. I'm just looking for how long is a Julian calendar. The actual tropical year is 365.2422 days. The problem arises when you do similar things for both. Yeah, to talk about that a bit. So Dav __ asked if I'm a teacher. I'm not a teacher. I do have a PhD, and I do sometimes teach courses, but I would certainly not call myself a teacher. I am someone who does things that is vaguely related to education, but I don't actually teach, right? So that's, I was just on that Wikipedia article. I promise, I was just on that Wikipedia article, and I just didn't look long enough to find the information I was looking for. Yeah, so okay, wait, no, how is this different? Oh, okay, never mind. I was on a different Wikipedia article. 365.25 days. Okay, fine, you're right. You're right. The length of the Julian calendar is the average length of the year. The Julian calendar. The length of the Julian year is the average length of the year in the Julian calendar that was used in Western societies until the adoption of the Gregorian calendar, and from which the unit is named. Okay, fair enough. Yeah, so, okay. I have so many topics I'm jumping between. I'm going to jump first. Are you a teacher? The answer is no. I do a lot of education. I love educating people, but in my opinion, I do lectures okay. Like, my lectures are fine, but I don't really enjoy giving lectures. I'm more of a guy that enjoys, kind of inspiring people to learn type of thing. So I kind of feel like my YouTube channel is not really so much about education as it is about learning, And I think there's kind of a clear difference between the two. Education, you feel like when you're in education, you feel like you're being taught. But at least for me, education does not mean that you're learning anything. Whereas I feel like learning is something fun and enjoyable that you do in your free time. But education is different. I don't know. There's just a subtle distinction, I guess, that makes sense in my mind, but doesn't make sense when I say it, I guess. Let's see. C++, yes, I am using C++. I have definitely considered making a port of GathVL into Julia. In fact, there is a Cairo variant in Julia that we could use. There's a lot of things like that I've considered doing, but I feel like I just don't have time to do it right now. I would love to do it, but I just don't have time. And so what we have with GathVL is pretty good, and I like it, and I think we can use that. And then if I ever work on the algorithm archive full-time, if that's my job, I'll then devote time into making new visualization scripts. Exactly that, Jetson. Yeah, because they want them to be separated in the first place. Why did that happen in the first place? Right. And so the other topic that I want to talk about is work-life balance a bit. So like I said before, I find that I feel guilty. Like I feel guilty when playing video games. But for some reason, I feel especially guilty when I'm programming for something that's not related to work. Because playing video games, like, you can justify that in your head as, I need a break, I'm taking a break. You can make that justification. But if you're doing something programming related for fun on the side, that's not you taking a break. Your mind is still churning in the exact same way it was churning for work. It's just now you're doing something that's not work. You're doing something that's unrelated. And it makes me feel like I'm wasting time unnecessarily on something that's also unnecessarily taxing on my brain, right? That's what it feels like. And I know that's not the case. I know that actually it's probably best that I do a programming project on the side that isn't related to my actual work. But yeah, the other thing I want to point out is that there's a lot of people, specifically in the coronavirus era, that are working from home. And I just feel like if you are working from home and you're in the tech industry, just be very, very careful to maintain work-life balance. Like, I feel like a lot of people can accidentally just forget that they are human and they shouldn't be working. I would say 40 to 60 hours a week is about reasonable, but if you're being asked to work all day and all night, and because you're now working remotely, you're always on call for your job, I mean, you just need to sit down with your boss and say, look, I'm still the same person I was before I started working remotely, and that means I don't really have time. You know what I mean? Like, I don't know. Just keep in mind that even though you're working remotely, that doesn't mean that it basically means you have to really make sure that you have your work-life balance. You keep that work-life balance, Gaussian year is the sidereal year for a planet of negligible mass. What? And unperturbed by other planets that is governed by the Gaussian gravitational constant. What? What is this nonsense? Where'd you find that? Gaussian year. Understand what you're saying? What do you call work? Yeah, so my work is, it's just in Wikipedia year. Here I found Gaussian year. A Gaussian year is defined as 365.2568983 days. It was adopted by Carl Friedrich Gauss as the length of the sidereal year. In his studies of the dynamics of the solar system, a slightly different value is now accepted as the length of the sidereal year. What is a side? I don't even know what a sidereal year is. Is the time taken by Earth to orbit the sun once with respect to the fixed stars. Okay. Hence, it is also the time taken for the sun to return to the same position with respect to the fixed stars, and after apparently traveling once around the ecliptic. I don't know. Ephemeris days? I don't know. Wait. It's sidereal? That's how you pronounce it? I'm sorry. That's just a weird, like, it says sidereal. Like, why? It's fine. Sidereal year? Okay, fair enough. That's probably correct. Fixed stars. Okay, I'm not going to look into this. We need to get Gauss's Easter algorithm done. As far as what I do for work, I work on Klima, which is a climate modeling alliance. Climate Machine is what it's called. It is a climate simulator written in Julia, works on GPUs. This is the stuff that I work on regularly. It's a good job. I appreciate it. I like it. But yeah, it is a job, right? And I keep having to remind myself that it's a job and that I need to work on it. So that's where I'm at. Sounds interesting. Yeah, it's cool. I mean, if you're interested in looking at the code base, you can just go to Climate Machine, Caltech, whatever this is. Just here you go. That's the code. It's a bit messy. I'm going to be honest. Part of the things that I'm trying to push in the next few weeks, I'm trying to make it more documented so people can actually use it. Klima, is that like Ligma? No, I don't think so. Thank you for the link. Yeah, feel free to take it out. Check it out. It's definitely interesting. I think it's cool. But yeah, we'll see how it goes. Man, I've gotten like 10 emails in the past like 10 minutes related to work stuff. It's just, I mean, again, this is what I'm talking about with work-life balance. You know, like I feel like you really have to make sure that you are like actively maintaining your work-life balance, and if you don't, you're just gonna lose it. You know, I don't know. That's my thing. What do you call working, and what do you call fun? What is the definition for you? Firefox, why are you eating 51% RAM? I don't think it's eating. What is it eating? HTOP. Mine's fine. Admittedly, I don't. Firefox is freaking. Jeez. Okay, sorry. I just keep getting more emails. Okay. On work-life balance, I have always worked at home until the coronavirus issue. If you don't mind sharing. No. So the thing is, my work-life balance was fine, I think, before the coronavirus issue, not because I always worked from home, but because I always actively maintained it. And now when I try to actively maintain it, I'm getting pushback, whereas I used to not. And that's the difference, right? Used to be, I would go into the office at 5 in the morning, and I would go to the pool at 6. So I'd go into the office, like I'd walk to the office somewhere between 5 and 6. I'd go to the pool from 6 to roughly 8 is when I'd be in the office. Then I'd be in the office from 8 to 5. And you know, I usually wouldn't go to eat lunch. I would usually eat lunch in the office just to get that little extra time there. And then I would leave at 5. That's the day. That's what I do. You know, and then I'd leave at 5, and then I'd come here to stream from 6 to 8. That's what I did for the first month or two that I worked here, and there wasn't any real pushback there. You know, and then on weekends I wanted to spend more time working on stream stuff and stuff like that. You know, but that doesn't work anymore. Like that schedule just flat does not work because of all the meetings we have to do now because everything's remotely, right? And like before, I had like no meetings. Now I have like 3 meetings a day minimum. It's a weird situation where I have to do more work now than I did before, a significant amount more work, such that I'm no longer able to maintain work-life balance anymore, where I used to be able to do it pretty straightforwardly, right? As far as what do I call working, what do I call fun? Like, to be fair, what I call working is, it is very close to what I call fun, but if you're trying to get at that, if you're trying to get at the fact that, for me, my working and fun is very similar, yeah, I'll give you that. They are very similar. But on the other hand, it's a matter of, am I doing this particular thing because I want to do it? Or am I doing this particular thing because I feel like I have to do it? And that's the difference, you know, between work and pleasure. Like the stuff that I'm doing here for fun, the algorithm archive stuff, it's technically for fun, but also like it is technically for work. I do genuinely want to turn the algorithm archive and the YouTube stuff into a career for me. And so I know I'm kind of grinding through some of the stuff, and that's fine. Admittedly, I'm grinding through nothing right now because I'm writing no code, but you know, like, it's a thing. Hey Marion, how are you? Let's see. That's how I've been it's been for me working from home. I've been doing it for a few years and I'm not sure I like it. Actually, I genuinely like working from home. Before coming here to MIT, working from home was that was the only way I could get any work done. Because if I go into the office, people kept coming up to me and they're like, hey, I have a question about this. I have a question about this. I have a question about this. And I just couldn't get any work done from the office. In addition, I can't do open office plans. If there's even a possibility that someone's behind my back looking at my computer, I can't work. I can't. It's impossible. And there's things like that I just can't do, which is why working from home is a perfect solution. Get more done. And not only do you get more done, you also keep your peace of mind. It's nice. Took a vacation up until Easter. Well, nice. We're talking about Easter. Okay, so let's just keep getting some visualization up and running. I'm just going to create just the sun, the moon, and the earth. That's what I'm going to create first. That's the first bit. So what I'm going to do is I'm just going to go ahead and move up here, and we're going to call this the orbit scene. So we're going to say void. Ooh, I do not remember C++ at all. So we're going to call it orbit scene. Okay, let's pretend I know what I'm talking about. Camera ampersand. Where's our ampersand? Cam. And scene ampersand world. Okay. One thing I do like about C++ is these squirrely brackets. I genuinely like these little brackets here. It's nice. Okay. What do we have here? I think what we can do is we can just do world dot add layer. Okay. And we'll do that. And now we'll do world dot add object. And we're just gonna add a ball to that object. But we'll call it the sun, not sin sun. And we're gonna add it to layer 1. Okay. So what I just did here is I created a background layer. We already had a background layer, which is layer 0, and then I created another layer on top of that to draw from. Okay, so now what we're gonna do is we're gonna go ahead and create the sun. So we should be able to do auto sun, and this is gonna be equal to std make shared, and it's gonna be an ellipse. Although I think we also have a circle object, but I think I'm just gonna use the ellipse. And it's gonna be at a particular location. Now, what's that location going to be? Let's find out. So it should be a vec of two particular, it should be a vec of a tuple in here. Let's see, and what else are we looking for? The next should be the size, so we'll do vec of 0, 0. I'm just kind of making this up as I go along. I don't know what the 0 is for or the true is for, but we'll just kind of follow the notation that we have here. And I think I'm gonna turn this into a 1, 1. Actually, let's turn it into a 10, 10. That's what we're gonna turn it into. Now this is all in pixel space, so for our vector, just to write something down, we're gonna say it's 640 by 360. Okay, so this should create a sun, and then we can add an animation to the sun. So let's go ahead and do that as well. And hopefully this will work out. So we're gonna do sun, and we're gonna do add animator. And then after adding the animator, we're going to do a vector animator. Right. And we're going to say from time points, we'll say 0 to 30. So we'll have 30 frames here. We're going to do at ball or at sun. Pointing to location. No. We want to do size. And then we're going to say it's going to go from vec of 0, 0. To vec of we'll just say 50 50 or something like this. Okay, so that should add the animation, and then down here we should be able to do for int I equals 0, I less than, we'll do 100 frames, then we'll do plus plus I, and here, and we'll do world.update I. And then we have to encode the frame. Should be cam.encode frame. I used to know what this was, but I've forgotten the syntax entirely. This should technically work as long as it compiles. And this should give us a ball that starts at 640, 360, which is right in the center of our 1280 by 720, and should expand up to 5050 in 30 frames, so half a second is what we should see. Assuming we're 60 frames a second, which I think we are. Now down here, I do need to call the, instead of first scene, we called it orbit scene. So let's call that DT here. And let's delete this guy there. Okay, so I'm going to create another terminal up here. So I have this kind of in the background that I can mess around with. Let's go to medium. Make this down a little bit here. Cool. We're going to CD into project, Simuleos. And we're going to go into Computus. Great. And I call this Gauss visualization. So let's see. I'm going to go over here. And I'm going to update the, instead of saying Sierpinski, I'm going to say Gauss visualization. So we'll call it Gauss viz. And same thing over here. So it should be, if I run this command, I get some sort of output in, and it should be temp video.mp4. So let's see what we get. Then we're going to do gaussviz.cpp, and then this guy here. Sorry that I have to do line by line. And let me go ahead and modify this path so it's in the appropriate path. So we're going to say home James projects, and we'll do that for all of these guys. So I should be able to just go here. Should be home James projects. And same thing over here. Projects. That should compile. No such file or directory. Oh, I misspelled Gauss. Crap. Okay, let's try that one again. There it is. Gauss viz is right in the center too. I have to go right to the middle. Oh well, it's fine. Gauss viz here. Right, it's screwed up because I misspelled everything. So let's try this one again. Camera was misspelled. Camera cam. Sun add animator. Expected something. What is it expecting? Add animator. Expected comma or semicolon before sun. Right? Expected primary expression. Okay, what are we missing now? Add animator. I also forgot a semicolon there. Right, this is me slightly, but not definitely, remembering C++. Let's run MPV, and we'll just do temp video.mp4. We should see, bam, look at that. There's our sun. Nice. All right, I'm actually almost happy with that. That's not bad. Let me go ahead and catch up on chat, and then we'll go from there. I like C++'s curly brackets. Let me go ahead and catch up on chat. I'm sure there's a quantum mechanical observer joke in there somewhere. I'm sure. I haven't done C++ in so long. I'm very rusty. Dude, as you can see, I'm pretty rusty myself. Let's see. Is it just because you've been doing Rust? I've been, yeah, okay. Obviously, I've been doing Julia, but I mean, you were talking to someone else. It's a rhetorical question because he said, I like C++'s curly brackets. I think I see some typos. Thanks, Flask. All right, but not the function definition. Compilation error in a few seconds. The sun getting larger, or are we getting closer to it? We're getting closer to it. What I'm also going to do here, I'm going to do what I always do, which is when I make an object, I always make it grow big, and then I make it just a bit smaller. So I'm also going to create this vector animator here. Where am I? Here. I'm going to yank and paste, and we're going to change this to from 30 to, we'll do 35. We're going to drop it from 50-50. And we're going to drop it to, let's do 40-40. Something like that should do. So now if we run this and that and this, we should see, yeah, so it goes, ooh, that might be a bit too quick. Yeah, probably don't want it to shrink as much. So let's change it to 45-45. Something like that. Okay. Yeah, it's still kind of like, oh, that's because I didn't compile it. Bop. What was that noise? I'm sorry about that, guys. I don't know what I'm talking about anymore. Let's try that again. MPV. Yeah, that's okay. We'll work on it. It's not. Maybe this should be 20 frames. Let's do. I don't know why I'm focusing so much. I don't really care that much, but you know, like, why not? See, having a makefile would definitely help here, but you know, yeah, okay, it's fine. We'll work on that in a second. So now we have to create the Earth and the Moon. So let's go down here and say Earth. And honestly, we're just going to do the same thing we did for the Sun. So let's just go ahead. There's also another thing I need to figure out. We have cam.size. So we should have world.size. And I should be able to say world.size divided by 2 in here. Just to make this a bit world.size, I think. Yep. And then hopefully I can divide that by 2. Let's do the same thing over here. And I just want to put this on the next line because I feel like putting it on the next line. Write this, go over here. Let's see if that actually compiles. It does not, because we might not have a world.size. Maybe it's, what would it be called cam.size. Why is this 50 frames a second? Who would encode something at 50 frames a second? That's bizarre. Okay. Beetlejuice feelings? Okay. So then, world.size. Do I need a... Is 50 standard? Maybe it is. Maybe I'm just an idiot. Is this it? No. Okay, what can I actually do with this world setting? Maybe it's... No, it should be world... Surely I have a world.size somewhere. Or is it cam.size? It's probably cam.size now that I think about it. So let's try that. Cam.size? And let's see if we have another one over here. Otherwise, I have to look into the GathVL source code, which is fine. It's just, you know. Okay, crap. Maybe I have it somewhere else. I'll create a new terminal. I'm just gonna make it huge because I feel like having a giant terminal available. Yeah, sometimes you just need a big terminal available. That's also not as big as I thought it would be. There we go. Oh, now it's big. Look at that. Nice. Okay, we're just gonna make that down here. Okay, so now we're gonna CD into projects, Simuleos. Let's go into CD Fractal. Let's go to VI Sierpinski Ensky.cpp. I think this is actually a typo on my... I don't know how to spell that word at all. World.size. Oh, there's a world.size.x and a world.size.y. Of course there is. That's why. Okay. World.size.x and world.size.y. I think it's x and y this way, so it should be... That should be right. Except I need to remove that. And move over here, G++, that should compile, /Gauss visualization, and then MPV. Should still be in the center, same visualization as before. Nice. And just so we have something to kind of look at, what I might do is I might create another terminal, because, you know, terminals are fun. And I'm going to move this to where you guys can't see it. No offense, but sometimes you just need to hide some things from your viewers, you know? And this is one of those things. And now we're just going to have MPV temp video.mp4 loop 0. And we're just going to have that looping. I don't know why, but I'm just going to have it looping up here in the top so you guys can see what we're looking at. And presumably, if I recompile everything, and I guess I'll have a compilation terminal here, be a bit smaller there. Where is it? Here. Crap. I'll get there, I promise. Move this up, and then we'll move this down. Okay, that's about what I was looking for. Okay, oh, I need to move it up just there. Okay, there we go, perfect. Okay, how's everyone doing? The sun is getting larger a few billion years, it'll consume the earth. Right, this is the visualization we're doing right. Crap. That's this visualization right here. The sun getting larger every couple billion years. Okay. Okay, so let's do the same thing for the earth now. So we're going to do, let's see, how many is this? Probably yank 5 yank. I don't know, I'm just making up things now. Paste down here. We already added the layers, so we're just going to call this earth. Okay. And we're going to say world.size. Let's give it an offset as well. Just because I feel like offsetting it by a small amount. So we're going to do plus 100, and we're going to do plus 100 here as well. Welcome to Simuleos. We're just arting up the code. Should be fine. So here's our Earth, and now we're going to add an animator to that. So Earth. Oh no, it's too big. Okay, so we'll have the Earth come into the scene at, we'll say 10 to 20, and then from 20 to 25. Oh, actually, let's do 10 to 30, and then from 30 to 35. I'm just putting in numbers. We'll fix this later, to be what we want it to be. And sorry that this is so annoying. It's just, the code's annoying, but I like the visualizations it comes out with. It's nice. And this is actually one of the cleanest interfaces I've seen. Well, okay, that we've come up with. I'm sure Manum is probably a bit better, but you know, like, yeah, He had time to develop his. Okay. So we're going to do 50-50. No, we're going to make this 30-30. Yeah, something like this. And then this is going to go from 30-30 to 25-25. Okay. So this should, if done correctly, give us what we're looking for. So we're going to do G++. Oh, I forgot to add the Earth. So we're going to add the Earth here. Okay. And now we're going to run /Gauss visualization. And we're going to do... It should... Okay. Oh, did I run it? I maybe didn't run it. Gauss visualization ran. It's not... Am I... Okay, well, there's the Earth. Apparently, I have to keep running this, which isn't ideal. Okay, but we have the Earth. I want to make it a bit smaller and a bit further away, but we'll deal with that in a second. Let's see. C++ detected. Yep, /life. This is definitely C++. I'm not going to say it's clean C++, but it is C++. I want to make the sun bigger and the Earth smaller because I think that's... I don't know proportions-wise, but I think maybe that's what they are. So we'll make the sun bigger. Just for the fun of it. So we'll make it 60-60. And then it's going to drop down from 60-60 to 55-55. Maybe just making the sun bigger is all I need to do. Then we're going to make this a bit further away. Let's change that to a 5 and that to a 5. Compile this guy. Run Gauss visualization. And then I was really hoping this would update on its own, but I guess it doesn't. So I have to do MPV this. Okay, so there's our sun and our Earth right there. Okay, I'm also going to change the color because I feel like changing the color, and why not? But I don't remember how to change the color, so I'm just going to guess at how to do this because I've done this before, right? Surely I know what I'm doing. So we're going to say color CLR is going to be equal to vec of, and we're just going to give it an RGB of 0.5, 0.5, 0.5. I don't know, just throwing something out there. And then down here, we're going to say auto sun, vec world, and then we're going to give it CLR here. Dang. Ah, I was hoping I remembered syntactically what I was trying to do, but I don't. CLR. Oh, of course there's no color in this one. Right. Okay. Where did I put color? Do I have this other terminal up anymore? I do not. So let's just go into VI fractal ifs.jl. Let's look for color. Color is a vector of... Oh, that's Julia. Right. Wrong thing. So we're going to fractal Sierpinski .cpp, and then we're going to look for color. Color. Okay, so we had color black, which was... Oh, it wasn't even a vector. It was just this. That's all it was. Okay. And then when I read the color in, let's see, where did I use black? It was used there. Okay, let's try white. Okay, well, let's just see what I did. Sierpinski Hutchinson didn't work yet, but Sierpinski triangle down here should have. And what did I do here? We had a point. Where did I define the point? Ball at animatic auto ball. Ball color is going to be ellipse. Oh, color is the first argument? Oh, who did that? Why did you put color as the first argument? Okay, let's just put it here then. CLR. I'm not sure if this is going to work or not, so I'm just going to... I'm going to leave this syntactically as is, and then we're going to... Ah, dang. Ah. I'm sorry. You're right. I called it something else. Dang it. Still didn't work. Okay. Catch up on chat. Call versus color. Okay. Just for the record, I'm just now reading chat, and I realize I'm an idiot. There's a semicolon. Where was the semicolon? Ah, yeah, probably up there. Thanks. Okay, appreciate it. Man, what would I do without chat? The answer is probably fail miserably at writing C++ code, and eventually realize I'm just not cut out for this type of stuff, and then probably cry in a corner. /Gauss visualization, and hopefully If we control C and run this up, we should see perfect. Crap. I swear. Okay, let me go up here. We're just gonna call it, I'm gonna call it CLR. It doesn't matter. The sun didn't appear. This is like, I could make a joke about how, like, I don't know. There's some joke in there about how the sun doesn't appear, and I don't know. So let's see. Should have ball color is gonna be, yeah, it's a double, and we give it a location. The color, make shared ellipse. We give it a color. What happens if I just change this to 1, 0, 1? Is this gonna work? Control C. Oh, quit. G++. / Gauss visualization, and no, still didn't appear. Why? Where's the sun? Where'd it go? And how can I find it again? Okay, I'm gonna look at this code again. Let's look for color. Right, so down here we have color ball color is equal to this. We have some sort of ball color defined here. Does it need to have a 1 there as well? I think we're using doubles. Okay, let's see. This is the problem. I'm working with essentially undocumented code. So let's try this again. / Gauss visualization. And there we go. Look at that pink sun. It's about to explode on us. All right. So we just need an alpha value. Perfect. Okay. So let's try and get some sort of earth color as well. So we're going to yank and paste. We're going to call it sun color and earth color. Boom. Look at that. Ah, dang it. All right. So the sun color is probably not supposed to be pink. Yeah, I don't actually know what color we should make the sun. Probably yellow. The earth probably shouldn't have any red. It should just be green and blue. And then the moon color, which we're gonna need anyway. So let's go ahead and create a moon color. Try that one again. Should just be gray. So we should just be able to do 0.5, 0.5, 0.5. That should work for the moon color. Let's go ahead and add the moon while we're here. So it looks like we're gonna have to do yank 7 yank or something like that. Paste it down here. Not the right number. Probably yank 8 yank was what I was looking for. Oh boy, there are people in the chat who are cringing right now at my inability to write code, and that's fine. That's totally fine. I want you to cringe. I want you to write better code. Okay, and let's look for earth. Okay, so here, what size do we want? We're gonna want, let's add 200 here. And we're gonna add another 200 here. Vector 0, 0, true. The rest should be fine. Moon. Moon. And what time do we want it to appear at? We want it to appear at, maybe the sun should be white. You're already doing better than me on one thing. See, that's the thing. You can't do Vim, but I'm not doing Vim. I'm using VI. Like I'm not even Vimming this. Let's see. Semicolon. I think I'm caught up with chat. Again, thank you guys so much for helping me with the debugging. I really appreciate it. So let's see. This vector is just going to go up to 2020, just like the year. And we're going to go down here. It's going to be 2020 again. And this is going to be 1515. So its final size will be 1515. And we're going to make it go from 20 to 40. And then down here from 40 to 45. And then we're going to add the moon. Yep, here. So DT there. Add moon. Write that. Go over here. G++. I screwed something up. What did I screw up? Color doesn't exist anymore. It's now sun color. Sun color, and I should probably add that as well down here. So when we create earth, we're going to add an earth color. Yeah, that seems to fit. And then down here we should have a moon color. Why does that fit? But those... Oh, I see what happened. So moon color there. And then that. And I think something similar here, right? I need a couple extra spaces. Nope. Yes. What? Yeah, that's correct. Nice. Control C. There we go. That moon is kind of big. Right, maybe a bit too big. But we got our sun, our Earth, and our moon. Let's see. Please don't ever let it be 2020 again. It's bad enough in the first time around. I mean, to be fair, it could be worse. Like, undoubtedly, it could be worse. Like, yeah. Not even Vim. I thought it was installed by default on Linux distros. Maybe on Arch. Not Arch. Arch is the only sensible distribution that allows you to use VI. Now, admittedly, I do 100% agree. Vim is better than VI in every single way, except for the fact that I don't understand how to use Vim and I understand how to use VI. That's the only exception. Vim bugs me a bit with certain things. Like there's just, I don't know how to put it. There's just certain things that bug me about Vim, and I can't. You know? Let me get some water. Also, Hex 0xD8FOO, thank you so much for following. Really appreciate it. Let's see, what is this? I'm sure this is a clip that's gonna make me look like an idiot. Okay, what do we have here? Pretend that I'm somehow better than everyone else because I'm using Arch Linux. I don't really have to pretend. I mean, I am better than everyone else because I'm using Arch Linux. But that's beside the point. I mean, hey, true statements are true. I mean, like, no problems there. Okay. Right, so we have our sun. I'm going to make the moon just a bit smaller because I think proportionally it's a bit big. And then I'm just going to have to get them to rotate around. And that's going to be the next visualization to do. Oh boy, this is going to be a lot harder than I thought. Okay, let's keep going. I'm going to change the color of the sun as well to be yellow. Maybe like a... What is yellow? What is it as a color? It's going to be red plus green. Okay, so RG. So we're going to do this. It's going to change to a 1, and this is going to change to a 0.5. That should be our sun, our earth, and our moon. And then we're going to go and say... What else am I doing with my life? Right, I'm changing this to be slightly smaller. So instead of it being 2020, we're going to make it 15 by 15 because Addison does not like 2020. And then we're going to change this to 1010. So its final size will be 1010. Oh, and another 15 here as well. Okay. Let's do G++. Gauss visualization. And then we're going to do, there we are. Play it. Okay, that looks a lot better. Look at that. That's not bad. Okay. So now we just have to make them move around in a circle. All right. This is actually surprisingly easy, you know? Like, you expect it to be hard. This is easier than I thought. Don't worry so much about the scale. It's all wildly invisible at real scale anyway. Agreed. Okay, so now what are we gonna do to make this work, to make this orbit, right? That's the next question. How do we get this to orbit correctly? In particular, this is gonna be annoying as crap. So what we've got to do now is we've got our let me just make this bigger. Let me just full screen it for a bit and pause it here. Okay, so we've got the sun here, and we've got the earth here and the moon here. I think, honestly, as far as visualizations go, I forgot how much I like doing this. I really did. So we've got our Earth, our sun, and our moon. And I'm gonna have to make the Earth go around the sun, which will be step 1. Then I need the moon to go around the Earth, which is gonna be a bit harder. Might have to think about that one a bit, but should be okay. And then the next thing I need to do is I need to make sure that the moon's cycle is 29.3 days and the Earth's cycle is 365 days, such that I can then draw the final bit, which is going to be our are off by 11 days thing there. So I have to draw like an angle saying that the moon cycle and the moon cycle and the Earth cycle are off by 19 days or something like this. Okay, let's go. All right. Oh, I'm gonna get another sip of water before continuing. Oh. Okay. This isn't bad. I've been thinking about changing my stream to an art stream recently. Just doing visualizations like this. Okay. So we'll keep going. Again, we don't need any really fancy visualizations here. We just need something that works. So I think this is good enough. So now we have to make it move. The question is, how do we do that? So we're gonna need some sort of angular velocity. Oh gosh, why am I an idiot? It's times like these I wish I knew what I was talking about. So Arch Linux? Arch is Art Linux? Actually, there's a distribution for that, like Ubuntu Studio. Did anyone ever use Ubuntu Studio? I used to be kind of into it a while ago. Like I wanted to use Ubuntu Studio, but I don't know, like I just didn't, and now I'm kind of regretting it. Like there's a bunch of things that I'm regretting, and like I said before, if I ever had the opportunity to work on this project full time, like as my job, there's definitely some stuff that I would do that, you know, like I wouldn't do otherwise. Like I'd learn art, I would learn Japanese, but that's also because I need to talk to my girlfriend sometimes. There's a lot of things that I would learn, you know, just because I want to learn them. Like again, art, I have a viola. I've been wanting to learn how to play for ages, and I just haven't. I don't know, maybe you guys are the same. You guys have a whole bunch of things that you want to learn to do, but you always keep putting them off. And the answer is right now, or if you're thinking about that, right now is the perfect time to put that stuff on. You know what I'm saying? Like we got to start working sometime, and might as well make it now when you're not able to go outside. Just start doing your thing. Like that's what I say. I need to talk to my girlfriend sometimes. Look, to be fair, she speaks perfectly fluent English. It's not really her that's the problem. It's the family that I can't talk to right now. So maybe that's fine, you know, but you know, but I'm in the middle of moving. Oh, you're in the middle of moving right now. Ooh, Neurotic Nerd. I feel like you're a long time watcher of this stream that I haven't seen in a while. Hi, Elzu, our Earth over our sun is, right. It's impossible to see. Yeah, right. This visualization is fine. Everyone knows it's a toy model. We're not going to go that far away, from the sun. Cold. Oh, that is an emote. Okay. I'm looking at it over here. Let's see. But right now I'm watching stream. Honestly, Haxie, if you're deciding between watching this stream and going out and doing something that you really want to do, go out and do something you really want to do. Like, I'm not going to sit here and say that you should watch this stream. I'm happy you're here. But I'm saying that if there's something that you want to do that's like been on your mind for ages and you really, really want to do it, but you've just never done it because you've never had the motivation or you've never had the time to do it, you know? Please don't go out during quarantine. Right, okay, right. Exception there. Right, you should. Okay, exceptions. But I mean, like, anything creative, like, okay. Anything you can do at home that you've been wanting to do at home, but you've never done because you've never had time to do it at home, do it now. That's what I'm trying to say. I got a new job towards the end of last year. Then my wife and I bought a place recently. We've been trying to move. It's just been a busy time. Dude, I understand. Like, I totally understand. If you've seen... Okay, so we're doing Easter algorithms, right? But I wanted... Okay, so April 1st is coming up, right? April 1st. The first day in April. Also known as April Fool's Day. I have genuinely been wanting to create an April Fool's Day video that's exactly like the Easter algorithm. You know? Like, exactly like the Easter algorithm. It's just that this is the Leos, L-E-I-O-S-O-S upload algorithm. And so I want to create like some sort of stupidly complicated mathematical formula that actually matches or maps to the videos I've put out recently. So it takes into account the year that I haven't uploaded any videos on YouTube. And it also takes into account videos that I will be putting out in the future. So I just want it to be like, I don't know, just only post on Easter and go from there. I just wanted it to be like, I wanted to put some sort of stupid upload schedule. It's like you upload every, 3 weeks from now, 2 weeks from now, like a day and a half from then. Like just do like some really ridiculous upload schedule that just doesn't make any sense. But then I want to stick to it. Like I want that to be my upload schedule. So it's like the stupidest upload schedule you could possibly imagine. but like it's actually the upload schedule that I do. So like it looks like a joke. Like everyone thinks it's a joke. But then, you know, like they don't see a video from me in like 3 weeks, and then all of a sudden, bam, videos. Like, well, okay, well, where'd that video come from? Oh, it's according to this upload schedule. You know, like that type of thing. I wanted to try it. I don't know. We'll see. Okay. So what was I saying? We have the sun, and it's revolving around. The Earth is revolving around the sun, right? I need to find the new location of the Earth at every time step. You are back going to take the FFT of your upload history? Oh boy, that's going to be weird. You just only post on Easter? You're right, really should get started on a project. Look, again, if you're worried, if you have a project to start, do the project. Like, don't sit here and watch my stream. Don't get absorbed into YouTube. Don't get absorbed into you know, like, just the worst thing you can do if you're secluded from society. The two worst things you can do, okay, there's 3 things that you can do for yourself to assure that your life is miserable. The one thing that you can do, like, is having, okay, let me try to put this into a way that makes sense. If you're living alone, and if you are working from home, and you don't see people around very often, and you're just super far away from human interaction. Okay, worst thing you can do is die alone, right? But there are many things that will make you depressed, right? And a lot of these things are inaction. Like, for example, not working out, not keeping yourself physically active does usually lead to some form of depression. And for me, like, it leads to, I'm not going to say like clinical depression, but I will say it leads to a negative impact on your life, right? Having an irregular sleep schedule is another thing that will greatly negatively impact your life. And another thing is, just in my opinion, this endless cycle of consumption is something that genuinely breaks me. You know, like I don't know if this is for anyone else, but if I don't create something every day, if I don't make something every day, if I don't do something productive every day, I feel lethargic. I feel like it's impossible for me to get anywhere, right? And so, in my opinion, if you're sitting there and you're not doing anything, you're watching YouTube videos, you're watching streams, you're just kind of wasting your life away, like, you're going to feel like you're wasting your life. But if you just write a book, or try to learn to draw, or something, just something creative, something productive, with your free time, if you just do something creative or productive, I feel, in my experience, this drastically helps my mental health. Like, it makes me feel like I'm doing something, which is why, again, going back to the work-life balance thing, a lot of my side hobbies are still working hobbies, you know, like streaming. Yeah, we do a lot of talking, we do a lot of chatting, there's a lot of socialization that goes on, but at the same time, at its heart, it's just programming for fun, you know? And I feel like being productive and being creative and just making stupid animations like this, it's fun. It's something that you can do for fun and be productive at the same time. You're right, I feel all those things quite often in the past. Right, anyway, I'm sorry for rambling. I know probably most of you guys know this already. I don't need to keep, you know, beating the dead horse here, but really and truly, I know a lot of people are probably, you know, maybe working from home for the first time ever. There's a lot of people in tech. And I feel like I need to make sure that people here, you know, I don't know, but who will watch if everybody's doing their own thing. I don't mind that. I think, I don't, so I personally think that I don't mind if people aren't watching me. I really don't. Like, I don't care about that. I know, you know, people need to watch me to get advertising revenue, yada, yada, yada. But really and truly, what I care about more than anything else is motivating people to make things. And if I don't have a job, because every single person who has ever watched any one of my videos is going out and making things, I think that is a wonderful outcome. And probably the best outcome you could possibly think of, right? That's what I think. And I know that sounds really weird, but I'm always going to be able to find a job, you know? I maybe not always, but I've got a skill set such that I can make it as a software engineer, as a researcher. I can make it in many different areas, right? And I think that my greatest contribution so far has been cultivating a community of people who like to make things. And I think that's really useful, you know? Cooperub13, thank you so much for following. Really appreciate it. Okay, so now what we're gonna do, because I've sufficiently rambled about this, and I feel like maybe I should stop rambling about this, is we're just gonna make the Earth revolve around the sun. That's what we're gonna do. So what are we gonna? How do we do that? So x, we just need it to revolve around the sun with a certain cycle, right? So, a circle is r squared equals x squared plus y squared. We could just make it track a circle, if we wanted to. Also, yeah, sorry if I'm rambling too much. I do a lot of rambling on stream. I need to stop that. I like your ramblings, actually. Don't really know why, but it's fun. Well, I'm glad you're here, and I'm glad you enjoy the content, you know. If I know more about the arcane algorithm archive, right, that's partially it. Okay, so we have r squared is equal to x squared plus y squared. We can just have this track, but I'm actually trying to make this track with time, right? So how do I give this, what is, r is going to be equal to, why am I so bad at this? I can't remember what a circle is. Right, I understand polar coordinates. X, cosine theta, and then r sine theta. Right. And then I just changed theta with time. So theta with time. There we go. That's what I want. Right. Okay, that's what I'm looking for. Cool. So now I just have to change theta with time. And this should in principle do something. Cool. So let's just knock this out of the park. So if the Earth, the Sun, is that all right? And why? Yeah, you're right. Okay, it should be R. Should be R, cosine theta and R sine theta. Right, that's what I'm looking for in the x hat direction and the y hat direction. Thanks for catching that. Okay, one of these days I'll learn how to math. But you know, I got my PhD and I still don't know how to math, so maybe this won't ever happen. There shouldn't be a plus. You're right, there shouldn't be. It's going to be x is going to be equal to r cosine theta of t. Bam, bam. Y is going to be r sine of theta of t. That's what we're looking for. I just got in. Are you making an animation for the video? Yep, sure am. This is what we've got so far. Just going to full screen that guy. Look at that. We've got a sun, an earth, and a moon. All right, doing pretty well. So now we're going to make the earth track the sun, and then the moon track the earth. That's what we're doing next. And then we got to get the cycles right, but we'll get there. We'll get there. I think, honestly, I don't think we have too much longer. I think we can get this done in like an hour if we just focus, right? Like that's the thing. You can do most things in an hour if you focus, I think. I think that's actually a false statement now that I think about it. There's a lot of things, actually most things you probably can't do in an hour, but there's some things. Okay, let me just stop talking and let's get this done. So we're going to create theta. Double theta equals 0. Why not? Oh boy. Oh boy. Okay, so we have theta equals 0. We have an animator. So I should be able to add all the animations. And then we should be able to... Right. So we have theta. So let's go ahead and modify theta with time. So here we're going to do... creating a theta for the Earth. That changes with time. And I guess what we also want is an Earth frequency. Earth frequency is going to be equal to, we're just going to set it to 0.1. I don't know. I'm just making things up as I go along. So we're going to say for int I equals 0, I less than however many frames we're going to do here. So I guess if everything's available on frame 50, we're going to say 50 less than end frame, and then we're going to do plus I. Okay, and we're going to start on frame 50 because that's when everything is available. And let's pop up here and we're going to say end frame. Let's actually read in an end frame. Double end frame. There. Cool. Okay, down here we're going to read in the end frame as 100. Okay, cool. Is this Java? No, this is C++. Double Earth frequency. Is that valid? No, because I meant to have an underscore there. I'm sorry. Thank you. Okay. Thanks for that. Okay. So now we're going to pop down here, and I'm just going to add an animator, which is going to be a vector animator for the moon's, the Earth's location with every time step. So first we have to update theta. So we're going to say theta is going to be equal to, we'll do plus equals, and what are we adding here? It's going to be the frequency. So Earth frequency plus times some sort of time step, which we're going to call time step. And I guess I'm also going to read in the time step. Why not? So let's read in the time step with time. Oh boy, this is going to be a long day, isn't it? And I have to do a double here as well. Okay, double time step. So reading in a double time step. I don't know. I don't really know what the time step should be. So I'm just going to read in 1. And we'll just kind of figure out what this is supposed to be. Surface frequency 0.1. Theta should be, so we're adding, so that means we're going to be adding 0.1 every frame, which seems fine to theta. So now we're going to create our X and Y location. So we're going to say vec new location is going to be equal to, I guess, old location? Do we have the old location? I guess, there's some things that I think I need to define up here. So let's go ahead and define, so we have the sun defined at 0, 0. So let's go ahead and define, I presume we are at MIT now? Yeah, I'm at MIT. Will the precision issues from using orbital frequency instead of orbital period? Probably. I'm just writing something down, and then we'll see how this goes. So we're gonna do, oh gosh, what am I gonna do? So let's go ahead and define Earth radius as equal to, what did I define it as before? Let's say it's equal to 150. Okay. And we're gonna call this a double. Now we're gonna define a moon radius, which is gonna be the radius from the Earth, and we're gonna define that as 50. Why not? So you're in New England? Yes, I am in New England. I think I'm in OG England. Nice. Okay, so now for the Earth location. Location is going to be equal to, and that's going to be a vector. And it should be equal to the sun's location, which should be world.size. Can I just create a sun's location? Let's see if I can do that. So we're going to say vec sun location is going to be equal to world.size. Can I just do this? Size.x divided by 2 and world.size.y divided by 2. Something like this should work. And then down here we're just going to say sun's location. Okay. Now we're going to say Earth location. And this should be sun location. I think I'm forgetting some semicolons in here. But we'll do sun location, subtracting vec, or am I supposed to be adding vec? I think it's subtracting vec of square root of r times r, square root of r times r. Something like that is what I'm looking for. And then the moon location is going to be the Earth location. And then r times r is going to be the Earth radius. Ooh, that's going to be long, isn't it? Let's just pop this down to the new. Oh gosh, golly gee. Oh well, it is what it is. So let's just pop this in there. Something like that should work, I think. Okay. And I'm gonna do the same for the yank to yank. Paste down here, the moon's location, and then we'll go from there. Sorry, there's just a lot of grunt code to do here. We can keep chatting in a bit. So this is gonna be the Earth radius, so this is gonna be now changed to the moon radius. And we'll just do 5x here, and there, and then we'll add moon. There, 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 and there. Cool. Okay. There's a few closing parentheses where there shouldn't be. Also, you are right about that. This shouldn't be there. That shouldn't be there. and that should be there, and that should be there. And this, I don't know what I was trying to do there, but that's supposed to be a semicolon. And I think now it all matches up. I think I caught up. Okay. Auto sun. Ah, right. Sun location. And yes, that's because I am what you might call, and I would also call, an idiot. Okay. So here we have the Earth color, and I'm just going to put the location at the Earth location, DT here. And we're also going to do the same for the moon. Oh, oops, you there. Do the same for the moon down here. Right, so we'll do DT there, and then moon location. So if I run this, we go ahead and comment this block out. If I run this, we should get the same visualization, essentially, that we had just a second ago. Nice. Okay. Is equal to, the Earth location is equal to the moon location. Ah, right. It should be the moon location is equal to the Earth location. Bam! Look at that. Nice. It's almost like I know what I'm doing. But clearly, I don't. Ha! 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 Oh, I'm actually kind of excited about that. That's almost right. Sun location, y square root of radius squared. I was trying to, it should be, I was trying to do this, journal new page before. So x squared plus y squared is equal to r squared, right? So you have this r squared in here. So the value of x should be, you're right, I have it wrong. It should be the square root of, I need to think really quick. What actually did I want to put down there? So I have a radius, and I want the value of x to be equal to square root of, I guess it's r squared minus y squared, right? But I don't have a minus y squared. Oh, now I'm confused, and I shouldn't be confused because this should be straightforward. I think what I did is fine. I think. Is scene.h something you wrote? Also curious about what frameworks you're using to render. Right, so what we're doing here is we are using a library that Gathros actually wrote in the community, and he was helped with Gus Storin and a few other people. But it is it's called Gathviel, and basically it uses a Cairo backend. So Cairo is Cairo C++. Here, it's an API for doing vector graphics, I think. Yeah, it's vector graphics. I would love to answer some of my science questions. I was watching one of Stephen Wolfram's streams this week where he did a science AMA. By the way, I just thought of a cool idea for a stream you could do. Will there be precision issues? Okay, I think I'm caught up. I would love to have you answer some of my science questions. Yeah, we could do an AMA stream. In principle, all my streams are AMA streams. In fact, I think I even have AMA in the tags here. If you want to ask me any questions, feel free to do so. That's kind of why I'm here, to answer the questions as well. Isn't there a string replacement function in VI? Oh, there is. It's just, it was easier for me to do it that way. Some location. Oh yeah, it is. Well, I don't understand. Yes, you have. Okay. Let's see. So what I'm looking to do then is, why did I do square root of r squared then? So I did square root of r squared because, if x equals y, okay, I need to think actually. Why did I do that? Do I need to set them on the diagonal? I could just set them off, like offset over here. So it's like sun, earth, moon, and then it's fine. It's Gathfiel. Right. So if you go to here, I'll give you a link right now. Let me go to algorithm archivists here, and it should be under algorithm archivists, and we should see Gathfiel here. So this should be it. There you go. Again, it's not very well documented. We're kind of working on a lot of other things. Square root of r squared is equal to the magnitude of r. That is correct. Why am I so bad at math? So in the case that we have a equilateral triangle where we have an equilateral triangle where x squared and y squared are the same, then what we're actually looking for would be 2x squared equals r squared. So I'm actually looking for the square root of r squared over 2. It looks like. That's actually what I think x is going to be equal to the square root of r squared over 2. I think that's actually what I'm looking for. So I think I missed a factor of 2 in there. Or is my algebra really that bad? Right. In the case where x squared is equal to y squared, it should be the square root of 2r, 1 over r. I'm now second guessing my equilateral triangles where oh, you're right. It's not equilateral triangle. That's a right angle triangle. What's a right angle triangle called? What are these guys called? Right triangle. There you go. And in this case, let's see. I want to define why am I so bad at math? I haven't done this type of stuff in a long time, so just don't I'm sorry. This is I know x squared plus y squared equal to r squared. I think that was right. I think this math is right. I think I missed a factor of 2. But if x squared is equal to y squared, this is a true statement. If x squared plus x squared equals r squared, right, because x and y are the same, then it's going to be 2x squared is equal to r squared. And then it's just going to be x squared, x. Yeah, that's fine. Equals square root of r squared over 2. Yeah, that seems fine. We'll just do that. I'll just divide by 2 and pretend I knew what I was doing. So it should be square root of these guys, and we'll just divide by 2. There, and there, and there, and there. Hey, Schaefer, what's up? Go ahead and close this. And also what I'm going to do is instead of subtracting, I'm going to add these guys. So let's change that to a plus. Change that to a plus. Write this. Go over here. Recompile. Run /Gauss visualization. Visualize it one more time. Okay, that's a bit... Okay, let's change the radii. Radii is what I pronounce it as. We'll change this to 200. And we'll change this to 100. Oh. And then we're going to do G++. Gauss visualization. Throw that visualization up there. That looks pretty dang good, if I do say so myself. Not a pretty big fan. Okay. Since we have this kind of sort of, okay, I'm going to... Is there simplified math, like simplified English, Chinese? It's called programming. All right, I'm going to be right back, guys. I'm just got to go fill up on water and stuff. I ran out a bit ago. So I'll be back in just 2 minutes. Sorry about that. In the meantime, I guess I'll just have this animation full screen ready to go, and I will see you guys in just a second. All right, bye, guys. Okay, back. 1 second. Right. Let me see. What did I miss in chat here? I feel like I missed a bit. Um, let's see. That's Pythagoras with an isosceles right triangle. Good evening, sir. Hey, Scafer. There's a simplified math. Is there simplified math? No. Okay. I didn't miss too much. 1 second. Right. So I'm a bit weird. A bit of weird setup. So I have to move my desk back and forth. Let's see. Let's introduce them. I guess we need to simplify mathematicians too. Let's introduce them to weed and beer. I feel like a lot of them already know about both of those. No, wait, that seems like a bad idea. We don't want them to get creative. Oh man, soon everything will be written in green, which is the least creative color. Your Monte Carlo video is super useful. Loved it. Hey, thanks so much. That video took a long time to make. Man, all my videos take forever to make. I need to get better at this, is what I need to do. Erdus was always high on crack. Ooh, when he stopped for a month, he couldn't produce anything useful for a whole month. Oh boy. Okay. Actually, I'll just keep that animation up, and then I'll just put it up here in the corner like I have been doing. Again, guys, if I say or do anything that you have questions on, just feel free to ask, and I'll do what I can to answer it. Okay, so now let's actually do this visualization down here. So we have the Earth, and we're going to get that to revolve around the Sun, and then we're going to get the Moon to revolve around the Earth. So we're updating theta. And so the vector new location is going to be the Earth location, and we're going to do plus, and it should be, what am I looking for here? So it should be the Earth location plus, r sine theta plus r cosine theta, right? Or no, maybe I don't need to do a plus. I should know the exact value. Right, I should know the exact value. So if I go ahead and give the offset of theta, and we know what that's going to be, it's going to be pi over 4, negative pi, and I guess it's m pi over 4, something like this. Then we can just say theta is going to be plus equal this. And we say the new location is just going to be r sine theta, and it's going to be the Earth radius. I think I call it Earth rad. Oh no, Earth radius. Times. 1 second, I'm working on it. It's gonna be vec of Earth radius times cosine of theta, and then Earth radius sine of theta. Something like this is what we're looking for. Let's see. Off-topic question is, what would you recommend as a good resource for learning C++? Learning C++, again, I don't really have good resources for learning anything. C++ was my primary visualization language for a while. Now we've been using Julia. Someone in the chat could probably give you a better book to learn C++ from. But I just took a standard book. I don't even remember what the book was. And then I just started making things in C++. Whenever people ask me how to learn a particular language, my answer is always the same. Just use that language to make things. And that's the only real way to learn. It's like trying to learn math without doing math. It's hard, you know? Let's see. Then the PhD students take over and add even more complexity? Wait. So let's introduce them to crack. Oh, right. Now I want to be a mathematician for that kind of treats. My math professor once joked to me that his greatest contribution to mathematics was probably letting Erdos back in when he was locked out while visiting my professor's college. Oh no. Is Julia better than C++ in these tasks? I'm just curious because I don't know about Julia. Julia is a good language for most of the things that I've been doing. I really like Julia as a programming language. It's as fast as C++, and it's roughly as readable as Python, so it's good. Is it better than C++ for these tasks? That's a hard question to answer. I think, honestly, syntactically, if we were to write Julia code for this, syntactically the Julia code would be easier to understand. However, there's a big caveat there, in that that library doesn't exist, so we'd have to write that library as well, right? And maybe it wouldn't look as pretty. Maybe there's other. I don't know. I just don't know. But, let's see. I would like to get into programming, but I see myself as an idiot, and I don't take feelings of frustration and failure very well. It makes me feel very inferior, and my life experience has taught me not to get my hopes up because I'll just be disappointed. That's a very valid. That's valid. What you said there is incredibly valid. The problem is when it comes to programming, a lot of people have incredibly thick shells. Like I don't know how else to put it, but they're mean. People in the programming sphere are mean. When you talk to them about anything, they just get mean. And it's hard. It's hard to work in that environment. You just have to learn to live with it, you know? Like, for me in particular, I always constantly belittle my own intelligence. I know a lot of people on this stream have seen me do some things that they would probably consider to be pretty intelligent, and if I were in their position, I would consider to be intelligent as well. But the thing is, I don't think that. The moment I start to think that I'm good at something is the moment that I'm going to fail to be good at that thing, you know? So what I'm trying to say is, don't look at the failures as failures. Don't look at them as, I'm not good enough to do this thing. Look at it, I mean, this sounds really cliche, but look at it as an opportunity to learn. I mean, every single time you fail, it's not because you're too stupid to do this thing. Rarely are people too stupid to figure something out. Most of the time, you're failing because you haven't taken the time to learn. And so, if you see a failure, just take a second, try to figure out what you would have done if you could have done it correctly, and then execute that next time. I don't know. I feel like with programming, this is especially true, and I feel with most things it's true. It's just a matter of refocusing and rethinking of how you see failure. Because as a programmer, you're going to fail a lot. Every single day. You've seen me fail multiple times in this stream. I get so many syntax errors, it's impossible, like, to read my code. But that's just how it is. Sometimes your code is unreadable. Sometimes you just have to grit your teeth, get through all the compilation errors, and say to yourself, you know, I'm better than these compilation errors. I know how to do this, or else learn how to do it. I don't know. I'm sorry for rambling about that. I just think it's important to talk about. Free node C++. Yep, that's good. Best language is the one you're comfortable in. Why do you want to get into programming? I want to build stuff. Right. Yeah. That means, let's see, check out the GitHub repo. That means that I had been lazy for a little bit longer. Just stayed lazy. First off, you can't be an idiot if you have goals like that. Well, fair enough. Yeah. Imposter syndrome. One important thing to learn programming is to learn to deal with failure. You will fail a lot, and you must fail a lot, because failing is the main component of learning. Agreed, exactly like what I just said. I think you've also got to clear your head of all the stereotypes of what a typical programmer is, as in you learn from failures. In programming, you will face many problems, and will solve many of them, but some of them can't be solved immediately, because at the last, we're all humans, and sometimes understanding something takes a long time. Exactly, yeah. This algorithm that we're covering right now took hundreds of years for people to figure out. It's not trivial. Nothing we're doing here is trivial. And so if you're coming here and you understand everything, good on you, man. You know everything, but that doesn't mean that everyone knows everything. You know, like I trivialize things too much, and I know I shouldn't. But on the other hand, by trivializing things for me in particular, it makes it easier for me. Like, as a physicist, I have a bad tendency to look at something and be like, that's trivial. And I get that. I probably shouldn't say that. But on the other hand, by saying it's trivial, to me, that doesn't mean it's actually easy to do. It means it is doable. And it's doable if you get your mind in the right mindset, right? Like that's my definition of trivial, you know? So I don't know. Maybe that helps. I don't know. I'm trying to be motivating, and I'm not very good at it. So, you know, let's see. I can't take failure. It just makes me feel retarded. Look, man, when you fail enough, failure shouldn't make you feel dumb. Failure should make you feel like you're making progress, because the more you fail, the more you're trying to go in the right direction. Like, you have something in your head, you have a way that you're trying to go. It's just hard to get there, and the only way you're gonna get there is by failing. So you have to do the failure. It's like in video games, right? Like, your character will die 10, 20, 100 times before you finally realize the right way to go. And that failure isn't failure, it's learning, right? And so just treat it the same way. As I phrase it towards customers and employers when they do ask me why I think I can demand as much as I do, you pay me for all these mistakes I have made in the past, as I'm unlikely to repeat them. Right, that's fair enough. I agree with that. But I work with Python for the most part, but if I fall in love with C the moment I learned it, I like C as well. It's actually, I prefer C to, I kind of prefer C to Julia in some ways. Like, optimized C code is easier to write than optimized Julia code. Geek Panther, thank you so much for the bits. I really appreciate it. Let's see. I always seen stupid. I'm trying to catch up. I always see as stupid due to a cognitive disability, but I think a lot of people have a skewed idea of what stupidity means. I agree with that. To be honest, the whole tech IT scene is an absolute disaster socially. I've never seen such a noob hostile place except for like League of Legends. Agreed, completely agreed. Also, hi, hope you're doing good. Hope you're doing well as well. Thanks so much for asking. I'm doing well. Thanks for asking. You didn't ask. I don't know. I just thanks. IRL, I haven't really experienced that. I imagine people just got tired of reading someone else's bad code and get really angry all the time. Yeah, I mean, I'll be honest. I'm bad at this as well. Sometimes I get a bit miffed when people. I've told people how to do something multiple times and they don't do it right. Yep, it kind of gets me a bit miffed. I think maybe they have similar issues. Like, I'm impatient to people that don't know what I know because I view myself as an idiot, so they must be dumber than this idiot myself. That happens to me as well. I know that feeling. Stop saying that. All people are idiots. Just deal with this. I don't know. Knowing something, knowing how to apply it, and knowing how to communicate it to others are three completely different things, and people forget that sometimes. Agreed. And knowing how to communicate it to others is a key component that a lot of people, I agree, a lot of people just don't do. If you fail to do your very best to learn from it, and then it will actually be a useful experience. If you fail, do your very best to learn from it, then it will be actually, right, agreed. Failure should make you feel smarter. Failure is how we learn. And the more you fail, the more you learn. I made the hop from C to Go. I really love Go now. Right, I mean, again, use the language you want to use. It's your call. Mr. AZ, thank you so much for following. Really appreciate it. But it doesn't make me feel dumb. I can't stop that feeling. It just confirms my inferiority bias because you see this proves you're too stupid. Okay, I was that way for a long time, like a really long time. I was valedictorian of my high school and, I did a physics degree. I was, by anyone's account, an intelligent kid. And no matter what, I never thought of myself as intelligent. I still don't see myself as intelligent because I'm just me and I'm an idiot. I see all my failures. But the thing is, that is very strongly imposter syndrome. And I feel like, I suffer strongly from imposter syndrome. I've talked about it a lot here on stream. And I feel like a lot of people here are also suffering from imposter syndrome. And it's just a matter of, you're smarter than who you see yourself as. Invariably, as long as you can... Okay, that's not true. As long as you are presenting yourself in a clear way and other people are listening to what you have to say, more than likely other people have a better opinion of you than you have of yourself. I say more than likely, but there are probably a lot of people who see themselves as better than other people see them as. But from my personal experience, as long as I keep looking at myself objectively and saying, look, I'm actually doing okay, I tend to be able to work myself through any problem, right? Like, the thing is, I know I'm not the best at anything. I'm not. But I know that if given enough time and the right resources, I can do whatever anyone asks of me, right? Like, and that's something that you just have to look at yourself objectively and say, look, I'm not an idiot. I know what I'm doing. But sometimes, I don't know. I know I'm saying multiple things, but it just depends on who needs to hear what. And I'm not really sure. I don't know. I'm sorry. I'm hoping this talk is useful for some people. Maybe it's not. Maybe it is. But if someone here is getting something from this, just let it be known that I don't think anyone here or anyone at all is an idiot. I think you can do whatever you want to do as long as you want to do it enough that you're willing to fail at it a few times. What kind of software do you make in Go? Aside from games mission failed, it takes at least some smarts to even recognize failure. Right. Commodore 2265, maybe you are setting goals too high. Like, I want to build stuff is pretty vague. How about I want to build a linked list library or something? I learned from my failure until I got good at it. Now I'm failing professionally. I mean, failure, like, success is what? Success is falling with style? No, what is it? Flying is falling with style, right? That's what it is. That's what you learn from what is it? Toy Story, right? And it is what it is, I feel like when it comes to intelligence... Oh, wait, let me catch up. A lot. I'm working on a project right now that is a network manager, and we have thousands of specialized network devices. For Go, right. And I was, by all accounts, a dumb kid, special education. That's okay. I mean, again, I don't think... You can learn. Everyone can learn. I feel like when it comes to intelligence, knowledge, and experience, it's hard to get true productivity using just one and not the other two. Yes, I agree with that statement. As long as you are in... the Dunning-Kruger, not sure about spelling, Valley, you're smarter than you think. As long as you're not in that valley, you're smarter than you think. Yeah, special ed means you were a square peg in a round hole. I didn't fit in the modern education system either. Right. I feel like most people don't. I don't know what's realistic, and I've seen suggestions, and they don't catch my interest. Right. So maybe if you just want to build stuff, I love building things with code, but there are other ways to build things too. And if nothing that people are telling you to make sparks your interest, then maybe you want to make stuff. Doesn't necessarily mean programming. And the thing is, I'm not saying you're too dumb to program. That's not what I'm saying at all. I'm just saying that sometimes, you need to see what you want to make and then make that, like that's all I'm saying. Like if you want to make a 3D printer, programming will only help you in the last step of that, It sounds interesting. Let's see. I was just wondering, as I always see Go is mostly for web and backends. Okay, maybe you need to get some distance from the term failure. If something it doesn't work out as intended, it's a setback. As long as you see and take something useful from it, it's not a failure. Yeah, I agree with that. Let's see. I've done a lot of my own REST servers. I actually don't even know what a REST server is. Probably should. I've learned more on my own than I ever did at school. I agree with that statement 100%. I feel nothing is useful until they pay my bills. That's also probably true. Dunning-Kruger Valley, I was born there. Did you move out yet? Also important to realize there are huge discrepancies between academic attainment depending on your skill. Right. Problem is, I don't know how to make anything. Well, right. Start somewhere, right? Like that's how you start. You have to start somewhere. That's how everyone starts. Have you considered talking to a professional about that worldview? Even today, for a lot of kids, where they are born plays a role in their life chances, in terms of schools available to them, etc. I think honestly, the place that you're born really impacts you. Like as a kid, as an adult, where you're born changes. It molds you, and it means that if you were born in a suboptimal place, you're not going to be as optimal as an adult until you learn. I don't know. Like it's important in the formative years to learn what you need to learn, right? Otherwise, you get stuck in ruts and you don't know how to get out of them. Let me check something real quick. 1 second. I need to send one of my friends something. And that's something. Give me just a second. It's for work. But I can't seem to find the. Where's the? Crap! I can't find it. I might have to pop off the stream, to send this thing to this guy. Darn. Oh, maybe I put it over here. Wait. I'm sorry. I know you can't see anything that I'm doing. It's for a reason. Here, and then maybe. There. Okay, found it. Nice. So I don't have to quit stream to find this. Cool. Okay. Put it there. Okay, cool. I'm not sure you know the Dunning-Kruger confidence curve. Oh, I didn't. I thought. Maybe I don't. I know the Dunning-Kruger effect, but maybe I didn't know there was a curve associated with it. So let's look up the curve. So okay, fair enough. Wait, there's a curve? Is there a curve? Right, no, I've seen this curve. Definitely seen this curve. Is this the curve you're talking about? Even today, for a lot of kids, REST making web requests to read, create, update, and delete resources for the most part. And if you grow up in a town where no one does anything with their life, that's hardly going to motivate you to do something meaningful with your life. What's Project Euler? Project Euler is actually pretty cool. Someone in the chat can talk about it. It's basically just a bunch of problems to solve. It's fun. Yeah, it's pretty fun. It's like a bunch of problems to try. I've kind of wanted to do it, but I haven't. See, the thing is, I never actually know where I am on this curve, right? Because like, I don't think I've ever. I don't know. great thing is that if you can motivate yourself nonetheless, these days, once you have access to a computer and the internet, you can have free access to a huge amount of knowledge. Okay, guys, I unfortunately need to leave at 6 o'clock p.m. my time because so that means I have 30 more minutes of stream. It'll be a 3-hour stream today. That's where we're going. So I'm gonna get at least the Earth rotating around the sun, and then I'm gonna have to take a break, and then I'm gonna come back and I'm gonna work on this on my own time. So I have 30 more minutes in stream. I got to get at least something done. That's where I'm at. A great thing is that if you can motivate yourself nonetheless, these days, once you have access to a computer and the internet, you have free access to a huge amount of resources to get started. Now let's see, negative pi over 4. I think this should do something. So let's just add animators. And let's just see what we have here. So Earth pointing to add animator. And we're just going to do a vector animator. Okay. And we're just going to say from frames. It's going to be frames. I minus 1 to I. Right. And then we're going to do earth.location. Where are we? At earth.location. Oh, I guess it's going to be Earth pointing to location. Okay. And what we want to do is we're going to have to move it from its current location to its new location. So we'll say Earth location. And then it's going to point to new location. And then after this is done, we're going to change Earth location to new location. Equals new location. Something like this is what we're looking for. Let's go ahead and compile this guy. Crap. Earth location. Sorry, Earth pointing to location. What did I do wrong? Earth pointing to location? Add animator. Oh, does that not exist? Maybe it doesn't. Vector animator, size, location. It's all read out. G++, that should compile. Then Gauss visualization. Control C here. That did not do what I thought it would do. Okay, I gotta look at that again. Crap. So we added the animator. Saying, oh, okay. That would explain it. This shouldn't be 1, this should be I. Let's try that one again. Okay, so we're going to do this. Gauss visualization. And then MPV. Ooh, look at that. It's up there. Okay, we're going to try that one again. Clearly, the location wasn't correct because I forgot to add the sun's position. So let's add the sun's position to it. So it's going to be sun's location plus that. Sun location plus, this means this vector location. Add this. Okay, write this. And let's move over here, run G++, / Gauss visualization. And then hopefully, yeah, okay, it's almost correct. Nice. Beautiful. Okay. So now what I'm going to do is I'm going to subtract this. Subtract. And I'm going to change this to it's pi pi over 4. I'm going to look for let's see, 7 pi over 4. Let's see, what am I looking for here? G++ / MPV. Oh, that's so close. It just jumps. Why does it jump? Yeah. That's so close. Okay, let me catch up on chat now. Oodles Noodles. Thank you so much for following. Really appreciate it. Sorry I missed you a few minutes ago. Let's see. I missed a lot of chat. Let me see if I can catch up. For the past few months, I've been using online resources to teach myself math, physics, and chemistry. Dude, fantastic. Keep up the good work. And what do people do with that access? Use it to complain? Oh, right. I agree. You have so much access. The internet gives you, like, we have the entirety of human knowledge at our fingertips. It's incredible, you know? Let's see. I need to make a rough schedule of your day. Otherwise, you end up being aimless until about noon when you start to get anxious the night before. Make a schedule for the next day. I think that's good. That's good. I mean, I have a schedule every day. I don't know if this is useful for everyone, but for me, it's definitely useful. I might be guilty of that too. Let's see. Find the sum of all multiples of 3 to 5 under 100, under 1,000. Right, so I think I'm caught up on chat. I might have missed something. If I did, just let me know. Why did we jump? That would mean that the initial location is wrong. Okay. I don't understand how. G++ / Gauss visualization. Control C, MPV. No, that just made it worse. Right. Okay. So what am I actually looking for here then? 6 pi over 4. It should be 7 pi over 4. Am I wrong here? So pi is going to be here. So 7 pi over 4 should be there. So that should be the initial offset for theta. So theta is going to be plus equal Earth frequency times time step. What am I doing wrong with my life? What? So change this back to a 7. Is it because I'm subtracting here? Let me change this to a plus, and let's change this to a minus equals. Okay, we're gonna compile that. Gauss visualization, and we're gonna run that. No, okay, so that didn't. Okay, let me think. There's something wrong with this angle formula that we're using here. I don't know what it is. Maybe someone in chat knows. Negative pi over 4 for starting theta. I put down negative pi over 4 to start with, but it didn't. Here, I'll show you negative pi over 4. So if I put a negative pi over 4, we'll do compile that, run Gauss visualization, and then if we run that, it still jumps. It's actually the same as the 7 pi over 4. Nope. Something like that. So it still jumps. Let's see. I don't think Project Euler makes for a remotely good thing to get cracking at learning programming. Maybe not, but it helps a lot later on, I think, down the line. I think I may want to study physics eventually at university, if I'm being honest. Dude, do it. Physics is amazing. I did physics as well. It's amazing. Pi over 4? Okay, let's try pi over 4. But why would it be pi over? Oh, you're right. It's pi over 4. Yeah, because y's are flipped. Yep, so that's correct. And it's going around that way. So now I want to do something similar with the moon. And so let's just do it. Okay, so we're going to do reading the time steps. We're going to have double theta. And so we're going to have a moon theta and an earth theta. Just to keep... Okay, so now we have an earth frequency, and we're going to have a moon frequency. Okay, this is going to be equal to... I'm just going to make the same frequency for now, but we'll modify it. Add a semicolon at the end there. So now we're going to say earth theta is equal to that, and we're going to have an earth theta here as well. And an earth theta here. So that should compile. And now we're just going to... basically do the same thing for the moon's location. So let's just grab all this, paste it down, and then we're just going to change everything to appropriate Earth moon stuff, you know? And then we should have a moon going around the Earth, going around the sun. So we'll say moon theta is going to be equal to minus equal moon frequency. And let's do a vec new location. In fact, we could just use the same new location from before. I'm not going to say it's an old location. And so this is going to be the moon radius, and the moon theta. And again, the moon theta. Okay, so let's see, add animator is going to be to the moon now. It's also going to be to the moon location. And the animator is going to be from the moon to location. And I know, I know there's an easier way to do this. But this is how I'm doing it. So just all those people who are mad at me for not using appropriate Vim strats, you just deal with it, man. Just don't Did that do what I wanted it to do? I don't think it did. I don't think it did at all. So the new location is going to be the Earth's location plus vector. Oh, maybe it did. Let me change the moon's frequency to 0.2. Here. / Gauss visualization. And now we're going to do MPV. Oh, there we go. Look at that. All right. We got it going. So let's make it a bit slower. Increase, so the end time, we're just going to make 1,000 frame animation. And we're going to make this frequency 0.5 to make it a bit slower. And let's just see if we can do this right. So it should be, we'll do 12. What's the frequency here? Where is the frequency here? Let's just do the full thing. So the Earth frequency is going to be 0.1. And so what we want here is it's going to be it's going to be Earth frequency times 354 divided by 365. What? That doesn't make any sense. Why did I try that? What am I doing? What am I trying to do with my life? Why? I just want this to be so that we do 12 cycles. So if we do Earth frequency times 12. Times 12 times this number. Okay, right. That's what I'm looking for. Okay, let's see what that does. So we're going to run G++, Gauss visualization. And we're going to run MPV. So we should have... Ooh. Okay. Well, look at that moon. maybe let's increase the frame count here to 2,000. Let's let it go. Okay. Let's see what we got here. MPV. Okay, let me try this again. So we're gonna do did I forget to write? I feel like I forgot to write or something. So now we're gonna do this / Gauss, and now let's try visualizing it. And it should go long. No, why is it only going that long? It should be longer, shouldn't it? Let's increase this to 3,000 frames. Am I using the frame count in some weird way? G++. Let's see, Gauss visualization. MPV. This should go longer. I'm confused as to what's happening here. Why? Oh, am I? Oh, freaking moron. That's what I am. I'm an idiot. That's why. What did I call this? I called it frame count or something. End frame. I can't believe I'm so dumb. End frame. Let's go back down here to the 1,000 frame one. I just forgot to update that. Okay, so let's go here. Let's go to that. / Gauss visualization. It's going to take 10 times as long to render. But once it's rendered, I think we can just plot it and then we'll... So we should see... Oh boy, look at that. That is a beautiful animation if I've ever seen one. Let's make it a bit slower. So we're going to change this to 0.1. And let's just do that. / Gauss visualization. And then we should be able to just plot this. Loop 0. Is it? That's a bit better. That's a bit better of an animation. It doesn't loop though. I think we should probably make that loop, shouldn't we? Anyway, that's not bad. I mean, for an attempt, like a first attempt, that's really not bad. I mean, this took what, 2 hours to make? I'm a fan of that. Let me go and catch up on chat here. Let's see. That's probably highly dependent on the country you're in. Oh, I missed a lot of chat, didn't I? The moon is tidally locked with the sun. Yeah. Honestly, Project Euler is almost all math and just some programming as an aid. Got frustrated with that after some time. Actually, I think I've never really gotten into Project Euler. It's not that I don't like it. I like Project Euler. It's a wonderful thing. It's just that I never really got into it. It wasn't really my thing, you know? Honestly, Project Euler is almost all math and just some programming as an aid. I got frustrated with it after some time, Hey, Real Seam Indie, how are you? Let's see. Slash Life, thank you so much for following. I thought you were already following. Really appreciate that. I guess my problem is I need one-on-one help. You can find one-on-one help. Is it possible to get a physics PhD with a math undergrad? Dude, it's totally possible to get a physics PhD with a math undergrad. Specifically, if you were applied mathematics, I mean, you're basically physics anyway. Don't take that personally. Any mathematicians out there, don't take that personally. I was just joking. You know, like that's what you would call a joke. I'm sorry. I realize mathematicians don't have a sense of humor, so they wouldn't understand that. But just to be clear, I wasn't saying that. Okay, let's just keep going. Let's see. That's probably highly dependent on the country you're in, but as far as I know, you could, in theory, get a PhD without any prior university degree. You just have to find someone to give you a chance instead of preferring one of the studied majors. Let's see. Try write a FizzBub program. It's a great problem to tackle. You start by writing a program to print the numbers from 1 to 10. Just started learning C++. I didn't realize it felt so low level. Dude, I actually like the low levelness of C++. I just set up my new laptop and I forgot how to set up all my dev tools. Let's see. Maybe you could try Exorcism. It's a programming challenge with mentorship available. It's free. I don't even know what FizzBuzz is. Seems like I'm writing a lot to achieve basic things. Oh, for C++? Yeah. That's a fast moon. It slowed down a bit. Write a program that prints the numbers 1 to 100. Right. Just output counting numbers. Are you in America? No, I'm in America now. So I'm in Boston. I'm currently working at MIT. Let's see. The moon is almost hitting the sun. I'm okay with that. I don't care. It's fine. I'll let the moon hit the sun. It's like printing, for example, in a lot of C++. Look at the modulo operator. They don't teach languages that make sense to my mind. For me, programming feels like magic, but something like Z80 or 6502 ASM feels like magic. Feels less magical because I can touch the metal. I understand what you're saying, and in that case, you can learn it. Do it. Okay. You try not to insult them by insulting them. I'm so sorry. Thank goodness FMT is standardized in C++. I'd be insulted if you did anything else. Well, if it wasn't, there would always be boost. Make the moon actual speed. This should be relatively. So the ratio should be the same right now. The ratio should be the same. So what I want to do next, and I'll probably do off stream because again I got to go soon. But I'll probably do off stream. I'm gonna have a line that follows the moon. I don't know how to do this. So what I need to show is that after 19 years, I guess what I need to do. Have you seen Ben Eater on YouTube? Dude, Ben Eater's amazing. I don't have it on me. Do I? Ben Eater has the best. He's just such an amazing person. I met him at ThinkerCon, and I mean, I'll meet him again. There's another conference coming up. Such a big fan. Ben Eater. I was thinking about quitting YouTube. I really was. I was thinking about quitting YouTube. I was thinking about quitting everything. And then I met Ben Eater, and I'm like, dude, I have to keep going. Like, he gave me his business card, and just his business card was already enough for me to be like, dude, this is the most amazing thing I've ever seen in my life. I'm just going to have to do this as my career. This is my career now, you know? Von Hoganen. Thank you so much for following. Really appreciate it. What is this one? I'm always terrified when people send me clips, specifically of my own stream. Like, I know it's going to be bad. Oh, no, this is good. Ben Eater gave me. It's literally a circuit board, you know? Like, where's the battery for it? Like, this right here? I know I've showed it off multiple times, but it is the coolest freaking thing. Yeah, right? It's so cool. I don't even remember what the dots do, but they do something. I mean, look at this business card Ben Eater gave me. It's literally... I'm a nerd. So I think actually this is where we'll stop today's stream. We have a visualization that's good enough to put into a video. There's some stuff I need to do with it. I'm going to go ahead and commit this to Simuleos. And I'm going to get the algorithm archive article ready to go. And hopefully we will be, we'll be good to go. Well, the orbiter on the sun is rather an ellipse, right? You are totally correct about that. This isn't so much about what the orbits actually look like, as it is showing a visual depiction of the delay between the moon's orbit and the sun's orbit, right? So you're right, it should be an ellipse. Definitely should be an ellipse. And I'm just not going to do that. It's just, why would I make my life more complicated? Although I could probably put like an asterisk in there, and not centered. Right, and it's also not centered. You're totally right. You were completely right about both those. Let's go ahead and do git add Gauss see vis just git commit -m. Adding simple visualization of sun and moon. For Easter animation. Done. Okay. And not centered. In this case, the elliptical orbit isn't important since it's more for visualization rotation periods. Right. So is the orbit of the moon. You guys, you're right. You're right. Okay, you're right. This isn't a physical simulation. It is a simulation. It's not even a simulation. It's just a visualization. But I think I like it. I think it's nice. Okay, so that's it for today. Let's see who's live on Twitch. We have Handmade Hero, Lana Lux, Dr. WD40, doing a COVID-19 Q&A if you guys are interested. Jessica Mack, Anthony writes code, Rocket Sage. We can do a lot of people. Who do you want to raid? I told him to do an end-body simulation. Dude, I'm not doing an end-body simulation for this. I mean, we could. I could just go full Barnes Hut if we wanted to, but no. I'm taking... This is my first video in a while, and it's not going to be... What's going to happen is this is going to be my first video in a while. It's not going to get too many views, which is fine. It doesn't have to get very many views. This is just about putting me back on the map. Just getting back into the habit of putting out a video as soon as I can. Slash Life, thank you so much for coming in. I hope everyone had a wonderful time, and I'll be back tomorrow doing, again, probably a 3-hour stream, something like that. This was, again, a 3-hour stream. Maybe 4 hours, we'll see. Basically, tomorrow I'll be getting everything done. Absolutely everything done that I can get done so that I can have a video ready to go Monday. That's my goal. So that at the very latest, I can do the video editing on Monday during stream. We'll see. Anyway, guys, let's go and start the raid on Dr. WD40. Okay. Dang it. Raid Dr. WD40. Did I misspell it? Okay. Thank you guys so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you guys around tomorrow for the next episode of Simuleos. Hopefully this visualization will be out of the way. We can think about more visualizations. I should have hopefully everything ready to go for the video. The algorithm archive article should be up. I'm pretty excited. Hopefully I'll see you there. Right. Bye guys. Have a wonderful time. See ya.